want to use the quadratic function f of x equals negative 1/5 x squared plus 6x minus 1 to address the following questions. We want to use the vertex formula to determine the vertex. We want to decide whether the graph opens up or down. I call this the orientation of the graph. And also state what the equation of the axis of symmetry is. So our quadratic function is in general form f of x equals negative 1/5 x squared plus 6x minus 1. The value of a is always attached to our squared term, so that's a negative 1/5. The value of b is attached to our linear term, which is 6, and our constant is negative 1, which is c. So we are going to use the vertex formula to find the vertex, and the vertex formula has an ordered pair, hk, and we're going to find the x-coordinate of the vertex using the formula negative b over 2a. And we're going to find the y part of our vertex by plugging that h into our function. So we're plugging the x into the function to get the y. So for the h part of our vertex, we're going to do negative 6 over 2 times negative 1/5. The negative 6 over negative 2/5. When we divide fractions, let's write it as division first. We've got negative 6 divided by negative 2/5. We're going to multiply by the reciprocal, so that gives negative 6 times negative 5 over 2. So when we multiply, that's going to give negative 30 over 2, which simplifies to be negative 15. Oops. Yeah, that's good. So we have negative 15 for our value of h, the x-coordinate of our vertex. Then we're going to figure out k, which is the y value of our vertex, by substituting that into our function. So we're doing f of negative 15. That's negative 1/5 times negative 15 squared plus 6 times negative 15 minus 1. I have negative 1/5 times 15 squared. I'm going to multiply that over here. So we've got a positive 225 for negative 15 squared, and then 6 times negative 15, that's going to be a negative, and that should be 90 minus 1. And 5 divided into 225, let's see, 5 divided into 225, will go in there 45 times. So we get negative 45 minus 90 minus 1. And that gives a negative 90 and 45. The negative 135 minus 1, that's negative 134. So as I was doing that math, I got the feeling that I had made a mistake, because I don't know if any reason why, but this always seems to come out to be this number being half of this number, and when we put them together, this becomes the other half. And so that pattern I've seen in a lot of math problems that I've done, and it wasn't fitting, So I thought maybe I made a mistake. So I did make a mistake, and let's go back up here to see where the mistake is. Up here I have a negative 6 multiplied by a negative 5/2, and that should have been a positive right there. So I was a little bit careless that should have been a positive 30/2, which is a positive 15. So I'm going to make these corrections. This should be a positive 15. That does not change this number right here because negative 15 squared and positive 15 squared are both 225. But if we change this right here to a plus, that's going to change this to a positive 90, and it will change this up. So let me go ahead and correct that. So now we have a negative 45 plus 90 minus 1, and that should be a positive 45 minus 1, and we get 44. So now we found the vertex to be 15, 44, and we want to know the orientation. Does this graph open up or open down? We can determine that with the value of A. So because A is negative 1/5, which is less than 0, we know that the orientation is open down. So the graph of this parabola will open down. Now finally, we want to know what the axis of symmetry is. And with parabolas, the graph does have some symmetry going around the vertex. And so we call the vertical line that passes through the vertex the axis of symmetry. And it's a vertical line, and the equation of a vertical line is always x equals. And we're going to use that x coordinate from the vertex because the symmetry is around the vertex. So our vertical line, which is the axis of symmetry, is x equals 15. In this question it says, use the quadratic function f of x equals 2x squared plus 4x minus 3 to address the following. We want to find any x-intercepts and find any y-intercepts. So I'll start with finding x-intercepts. To find an x-intercept, you're going to let y equal 0. So because it's an x-intercept, it's going to be on top of the x-axis, and the y-coordinate has to be 0. And in our function, f of x is standing for y, so we're going to substitute in for f of x a 0. That gives me 0 equals 2x squared plus 4x minus 3. And I want to solve this quadratic equation. I'll try to factor it. So I would have to have 2x and x to get 2x squared. And to multiply to be a 3, I need these two values to be 3 and 1. So I can try 3 and 1 here. That would give me 3x and 2x. And 3x plus 2x would give me 5, or 3x minus 2x would give me x. And neither one of those would give me the right number in the middle. So I need to try something else. So I'll try moving the 3 over here. And putting the 1 here. That would give me x on the inside and 6x on the outside. If I add or subtract these, that's not going to give me the right number in the middle. So I've tried all the possible combinations. So I'm going to solve this by the quadratic formula instead. So factoring doesn't work. I can always fall back on the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. For this example, a is 2, the coefficient of the squared, b is 4, and c is negative 3. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 3 all over 2 times 2. Now I'll follow order of operations to simplify. This is negative 4 plus or minus the square root of 16. 4 squared is 16. I've got a negative and a negative, which I'll change to positive. And 4 times 2 is 8. 8 times 3 is 24. And 4 times 2 is 4. I'm sorry, 2 times 2 is 4. Underneath the radical, 16 plus 24 would be 40. And I'll simplify underneath the radical. 40 can be factored. See, 40 is 1 times 40, 2 times 20, 4 times 10, 5 times 8. But I'm going to choose 4 times 10 because of the 4. Square root of 4 is something I can calculate, so that's the factorization I want to use. Use 4 times 10 over 4, negative 4 plus or minus, and now I can simplify that square root of 4 to be 2. 10 is not a perfect square, so I can't simplify that. And then finally, I'm looking, all three of these numbers are divisible by 2, so I can simplify that fraction to become negative 2 plus or minus square root of 10 over 2. So I've got two x-intercepts, negative 2 plus square root of 10 over 2 comma 0, and negative 2 minus square root of 10 over 2 comma 0. So there are the x-intercepts. And then I want to find y-intercepts. So to find a y-intercept, you let x equal 0. I'm going to substitute a 0 in for x. It's 2 times 0 squared minus 4 times 0 minus 3, which is negative 3. So I have a y-intercept at 0, negative 3. A baseball player swings and hits a pop fly straight up into the air to the catcher. The height of the baseball in meters t seconds after it's hit is given by the quadratic function. H of t equals negative 4.9 t squared plus 14.7 t plus 1. How long does it take for the baseball to reach its maximum height? What is the maximum height obtained by the baseball? So the function that we're given, h of t, equals negative 4.9 t squared plus 14.7 t plus 1, is going to tell us the height, so h stands for height, at any moment in time after the ball is hit. So if we choose a t, choose a time, and substitute it in for these t's here, that will tell us the height at that moment. Now what this question is asking for is something very specific. They want to know the time, how long. They want to know the time it takes to reach the maximum height and what is that maximum height. So we use that word maximum, and that maximum is the highest in this case, highest height, the highest y value. Now, in this example, we were given a quadratic function. And we know what the graph of quadratic functions look like. They're either a parabola that opens up like this, or a parabola that opens down. We already know which one it is for this example by taking a look at the a, which is attached to the squared term. The negative 4.9 is the value of a. What I'm referring to is most quadratic functions can be written, or all quadratic functions can be written in this format. Ax squared plus bx plus c equals 0. A is the coefficient of the squared term. And so our example, we have a equals negative 4.9. Anytime a is negative, we know that we have a parabola that opens down like this. So a being negative 4.9, which is less than 0, means that we have a parabola that opens down. And looking at that picture, if we have a parabola that opens down, remember, we're looking for the maximum height. The maximum height is going to occur at the vertex. So I'm going to be able to answer the question that's asked, how long does it take the ball to reach the maximum height, and what is that maximum height, by finding the vertex of this parabola. So we do have a formula for finding the vertex called the Vertex Formula. And our vertex is usually written as an ordered pair, HK. And the formula is for the x-coordinate of the vertex. That's negative b over 2a. So you can see it's using the a and the b. The a is the coefficient of the squared term, and b is the coefficient of the x term. Once we get the value of h, the x-coordinate of the vertex, we can find k, the y-coordinate of the vertex, by plugging h into the function. So we're going to substitute this negative b over 2a into the function to get the y value of the vertex. So for our example, we're going to find h, which is negative b over 2a. That's negative 14.7 over 2 times negative 4.9. I've got my calculator here. So 2 times negative 4.9. That'll be negative 9.8. So 14.7 divided by 9.8 is positive 1.5. And that's going to be the x-coordinate of the vertex. Then I'm going to get the y-coordinate of the vertex by substituting 1.5 into the function. So I'm substituting into the height function 1.5. That's negative 4.9 times 1.5 squared plus 14.7 times 1.5 plus 1. So I need to do 1.5 squared. That's 2.25. 14.7 times 1.5 will give me 22.05. And 2.25 times 4.9 will be a negative 11.025 plus 22.05 plus 1. I'm going to add negative 11.025 plus 22.05, and that's going to give me 11.025 plus 1 is 12.025. So that is now our vertex. Our vertex is 1.5 and 12.025. So we want to make sure we know what these values mean. So ordered pairs are typically x and y values. In this example, x and y weren't used. We have t and h. So t is our x, our independent variable, and h is our y, our dependent variable. And so this 1.5 is referring to the time, and the 12.025 is referring to the height. So in this example, that baseball is going to reach a max height of 12.025 meters at a time of 1.5 seconds. So if I go back to these questions that were asked here, this first question, how long does it take for the baseball to reach its maximum height? It's going to reach its maximum height at 1.5 seconds. And what is the maximum height? That maximum height is 12.025 meters. A farmer has 1,756 feet of fencing available to enclose a rectangular area bordering on a river. No fencing is required along the river. Let x represent the length of the side of the rectangular enclosure that is perpendicular to the river. Complete parts A through C. So in part A, what we want to do is we want to create a function that represents the area. So in part A, we want to find the area function as a function of x. In our picture, you can see we have the river here. No fencing is required along the river. And we've labeled this side that is perpendicular to the river as x. Because this is a rectangle, we know that this side will also be x. And we want to label this side that is running parallel to the river. And we know how to label that because we have 1,756 feet of fencing. So the rest of the fencing is going to go along this portion. X of it will go along this, and X of it will go along this. The rest of it will go along this one parallel. So that's going to be 1,756 minus 2x. Now, area of a rectangle, if you have a rectangle and you're trying to calculate area, that's going to be the width of the rectangle times the length. So area is length times width, or width times length. So for our area function, we want to use x times 1,756 minus 2x. This gives me a quadratic function, 1,756x minus 2x squared. So we have a quadratic function. In part B, what we want to do is maximize the area. We want to find the dimensions that will maximize the area of our rectangle. We want to have the largest area inside of this rectangular enclosure. Now we have a quadratic function. and we want to find the maximum area. A quadratic function with a negative leading coefficient will have a graph that's a parabola facing down. And so this is our area, and that maximum area will occur at the vertex. So we can answer this question about maximizing the area if we find the vertex of our quadratic. There is a formula for vertex. A vertex is an ordered pair. We usually label it with HK. And the formula for H is negative B over 2A. So what I mean by that is that if your quadratic function is written as ax squared plus bx plus c, then you can use a, the coefficient from the squared term in the formula, and b, the coefficient from the x term in the formula, to get the x coordinate of the vertex. So that will give negative 1,756. That's our value of b. B is the coefficient of the x term. And then negative 2 is a, the coefficient of the squared term. We'll do 2 times negative 2 to get 1,756 over negative 4. And let's divide that out. 1,756 divided by 4 is 439, and that's a positive value. So that gives me, for this figure, that gives me this side here, 439. We want to find the side parallel to the river as well. We want to find this side, and that's going to be 1,756 minus 2 times 439. So 2 times 439 is 878. And we still need to do 1,756 minus that. You have to excuse me, I don't know how to use this calculator, so I have to do it one more time. 1,756 minus 878 is 878. So the length along the river is 878. In this problem, we're using feet. So this is feet, and this is feet. Our dimensions are 439 feet by 878 feet. And our final part is to find the area at maximum area. And there are a couple different ways you can do it. You can substitute this value of 439 into the area function, or because you have the dimensions of the rectangle, you could just multiply length times width. So you could do 439 times 878 to get 385,442 square feet as that area that is the maximum. On this question, we are given a graph that we see here on the left, and we want to use this graph to find the vertical asymptotes of the function. So what I did here is I pulled up from our notes the definition of the vertical asymptote. The line x equals a is a vertical asymptote of the graph of a function f if f of x increases or decreases without bound as x approaches a. Symbolically, if f of x approaches infinity or f of x approaches negative infinity as x approaches a, then x equals a is a vertical asymptote. So when we're looking on a graph for vertical asymptotes, we're looking for y to increase or decrease without bound. That means we're looking for y to approach infinity or y to approach negative infinity. So we've got our y scale, which is this vertical scale here. And remember, infinity is way up here and negative infinity is way down here. So on our graph, we're looking for the parts of the graph that are either going to infinity or negative infinity. So on our picture, right here, those two pieces of the line, we have the y approaching infinity here, and the y approaching infinity on this side as well. And both of them have x approaching where this dashed line is marked. They have x approaching -5 on this side. We use a little plus sign when it's above the number, and x is approaching -5 from below the number. We use that minus sign when we're below. So on this graph, because y is approaching infinity as x is approaching -5, we can say that the graph has a vertical asymptote at x equals -5. So that's the location of our vertical asymptote. Thank you for checking out my videos. Have a great day.